Not all that shines is gold. It's an expression that sometimes we use to refer to things that look real when they're actually not. It might be true about people, it might be true about places, sometimes events. But it's also true about some research. Not all published research is gold. And the truth is, I'm a professor. I'm a researcher. I do research and teach research. So don't get me wrong. Research is very important. I'm a very strong believer in the importance of research to advance informed decision-making. In practice professions, it's very important to advance evidence-based practice. But research is not immune to error. Every research study is prone to a degree of error. We refer to it as random error or systematic error. Random error is a fancy word for a chance error. We assume that it's benign. It does not have an impact on our conclusions about reality. And I agree with that. We tend to be forgiving with regards to random error. Systematic error, however, refers to bias. And bias is not so benign. Bias can impact our understanding of reality. It can lead us to make inferences about things that are not necessarily true. So, to understand the issue of bias, we need to realize that there are several sources of bias in research. The one source of bias I want to talk about today is the confounding bias. To better understand confounding bias, we need to think about who we are as humans. We do not exist in vacuum. We are variable. Take, for instance, our health state. If I come to you and I say, your health state is a function of your dietary lifestyle, I'm telling you part of the picture. Because your health state is not a mere function of your diet. Your diet might be a small factor that influences your health state. Your genes can also influence your health state. Your age can influence your health state. Your exercise and activity can influence your health state. Therefore, it's important when I want to understand the impact of diet on health state that we also account for other factors that might influence this relationship. Things don't exist in vacuum, because if they do, I can easily convince you that the shoe size of a school-aged child will predict his or her level of education. And if things exist in vacuum, I can also easily convince you that those who carry a cigarette lighter are at higher risk for acquiring lung cancer. How come? Let's look at the example of shoe size and level of education. When things exist in vacuum, data will support that. But what's missing is the age of the child. As a matter of fact, an older child will have a larger shoe size and an older child will also have a higher level of education. Age causes both the larger shoe size and the advancement in education. And that's the classic definition of confounder. It's a variable that confounds the cause and the effect. Confounders are two types. They can be complete and they can be partial. I mentioned the example of cigarette lighter and lung cancer. That doesn't make any sense to anybody. And that's why it's a complete confounded relationship, completely confounded relationship. Why? Because it's a function of smoking. When we ignore smoking, we infer that having a cigarette lighter will cause someone to increase his or her risk for lung cancer. Now let's put smoking in the equation. We know that smokers are more likely than non-smokers to carry a cigarette lighter. And we know that smokers are at higher risk to develop lung cancer. Control for smoking, and this relationship will vanish. It doesn't exist. Confounders can also be partial. For instance, again, smoking and lung cancer. But now, the smoking status is the exposing factor. Smoking is not the only thing that increases one's risk for lung cancer. I'll take one possible confounder. There could be several, but let's consider age. The older you are, the older people are, the more likely they become smokers. And then the older you are, the more likely you are to develop lung cancer. When we adjust for age, maybe the relationship between smoking and lung cancer will stay. The difference is the margin of the relationship thins. It becomes smaller. So to understand the real relationships about things, we have to keep in mind that relationships could be confounded, and we shouldn't ignore that. Now you might say, I'm bringing these fictitious examples because I'm trying to be extreme with regards to these explanations. Truth is, the research data, publications and reports are plagued with confounded relationships. In this era of commercialization, in this academic atmosphere where we have to publish or perish sometimes, we become or we succumb to the temptation and ignore confounded relationships. I'm going to share with you an example of a study that I found a little troubling. So the study is about tree pollen and the increased risk of non-violent suicide among women. So the title of the study is that tree pollen peaks are associated with increased non-violent suicide in women. The study intrigued me. I actually went and read the study. And I found that the authors of the study examined all kinds of relationships. They examined men and women. They examined nonviolent and violent suicide. And they also included all types of pollens. But the one single significant relationship in the study suddenly made itself to the title of the study. I want you to think, what makes tree pollen lead women to non-violent suicide? Sometimes we know the confounder, and other times we may never know it. You might just be left for guessing. So confounding is a problem, and we have to handle it. But how do we handle it? we need to be aware that research studies are two types. They're either observational in nature or experimental in nature. We refer to them in clinical settings as clinical trials. In observational studies, we can never completely eliminate confounding because we can only control for what we know. However, we have to be real about what we know. If I know that variables X, Y, and Z confound the relationship in my study, I need to see evidence that the researchers have controlled for them. They have accounted for them. Otherwise, you are left to doubt the level of evidence. If the study is a randomized controlled trial or experimental in nature, we have to understand that by virtue of randomization, meaning we give people equal chance to be assigned to one or the other group in the study, we equate the groups on all confounders, the ones we know and the ones we may not know. By virtue of randomization, we accomplish that. So confounding seems to be less of a problem in well-conducted randomized controlled trials. Where do we go from here? We have to become informed consumers and utilizers of research. Research is very important, but only when it's well conducted and only when the evidence in it is made of diamond. We have to be the diamond that resists the pressure of temptation. If we are researchers, we have to resist the pressure of ignoring confounding because it suits our presumed ideas. And if we are utilizers, we have to resist the pressure of ignoring confounding because the results suit my liking. Thank you very much.